Good morning, algebra. This week, the notes are going to be broken down into two parts. This first part is going to be more just conceptual understanding. Um, what does it mean to be completing the square? How do we do that? How did they come up with that name? Things like that. And the next set of notes will actually be doing examples of solving quadratics by completing the square. Okay? So, like the quadratic formula, this is used when we can't factor and we can't graph it easily. Okay? So, like the quadratic equation, this is also how you can change something written in standard form like this to vertex form. You can rewrite it so it's written in vertex form. This would be the way to do that. So here's an example of one that we can't quite factor nicely. We could graph it, but who wants to graph when you can just do something a little more algebraically? So completing the square, that is a process that works by adding a constant to both sides of the equation, if you're dealing with equation, but an x squared plus bx plus some constant to make it a perfect square trinomial. Now, remember, a perfect square trinomial is a trinomial that when you factor it, the two factors are the same thing. I think on that welcome video, I had an x squared plus 6x plus 9, because when you factor it, it goes x plus 3x plus 3. These are the same two things. That's why it's a perfect square trinomial. Okay? So that's what we're going to work on. How can we create perfect square trinomials? So that's what this next piece is called. So if I have an x squared plus 8x, what do I have to add here so that it becomes a perfect square trinomial? So think about it for a second. And here's how you can do it. Take this and divide it in half, which will give you a 4x. Okay? Now if you square that 4, you get 16. And it would be x plus 4 squared. So x squared plus 6x plus what? Well, think about what two things are going to add to this that are the same, because we like two things that add to this that are the same as 4 and 4. That's why I said cut it in half. Two things that add to this that are the same, well, 3 and 3. So that means this is going to be x plus 3. And to get that last thing, we're going to square 3, and we get a 9. What plus what gives you 12, where they happen to be the same thing? 6. So that means that's going to be a 6, meaning we're going to have to add 36. Okay. What plus itself will give you a negative 2. Again, if you divide this by 2, that's how you do it mathematically. It's a negative 1. And negative 1 squared is positive 1. Same idea. Cut this in half, gives you that negative 5. And you square it and you get a positive 25. So when we're looking at problems like this is how we are figuring out the constant. What does the constant need to be that we have to add? We take the b, essentially divide it by 2, and then whatever number that is, we square it, and that's what we're adding. So 8 divided by 2 is 4, 4 squared is 16. 12 divided by 2 is 6, 6 squared is 36. So that's how we figure out the constant. Now, why is it called completing the square? Because that's kind of a weird name. And it kind of has to go back with multiplying factors. In order to be a perfect square, the side lengths have to be the same. So whatever this length is, that means this length has to be the same thing. That's by definition a square. If this was 5, this has to be a 5. If this was an x plus 50, this would have to be an x plus 50. They have to be the same thing. Okay, so how we complete it, well, if this is our problem, we know how to do this, which divide by 2, 64 is 8. Divide by 2 is 8. 8 squared is 64. And this is 8. So x plus 8, x plus 8. We fill that out. Now we can actually complete the square. And this is another way how you can figure out what this is, 64. Once you figure out what that piece is, which is an 8, supposed to be, doesn't really look like it, but it's an 8, you can then complete it, okay? So looking at this one, think about what does this need to be. It has to be a -2. So what does that, because we cut that in half. So what does that? Well, add our -2 here. We get x squared minus 2x minus 2x. That gives us our -4x. And then what does this need to be? +4. So that's why that needs to be a +4, okay? So again, this is just more general stuff, thinking about completing the square and the little pieces. Okay, make sure you go to the next set of video, or the next video. That is going to be all just examples, and let me know if you have questions.